calculate the volume of the solid generated by rotating the region between the curves y equal x over 2 and y equals root x. And this is going to be rotated around about the y-axis. So you have to know the general shape of y equals root x, and then you have to recognize y equals x over 2 is just a line, and a line that goes through the origin, because the plus b part, mx plus b part, is b is 0. So we have some kind of y equals root x, and then some line that goes through the origin. We just need to know, will it look like this or like that? And so the way we can find that out is by picking values of x. When x is 1, a half is smaller than the root of 1. So the line should be smaller than the root function. And so basically that's how we know then that it looks like this. We're rotating about the y-axis, and so you visualize that being rotated, and what happens is we get a shape that looks something like this, where we need to, if we're going to do it by disc or washer, then we must take a rectangle that's perpendicular to the axis of rotation. Since that rectangle is horizontal, it gets moved upward, and so we then find out that this must be washer, because there's definitely a gap. There'll be a hole there when we rotate, and not only that, though, we'll be in the variable of y, washer in y. But what we need to know is where these things intersect each other. We recognize that, yeah, when x is 0, they're both the same. We don't know this other point where they intersect at, so we need to do just a bit of algebra to find out where x over 2 is equal to root x. And that's solved by basically thinking of it like cross multiplying. It's where x is twice root x. And if you can't do it mentally, then we could do it algebraically, squaring both sides, getting that x squared is 4x. When you square the left hand side, you square the 2 and you square the root. And this, you don't want to divide by x here. What you want to do is instead ship the 4x over to the other side, set it equal to 0. When you have a quadratic, it needs best solved by setting it equal to 0. And at this point we can factor out an x and be left with x minus 4, and then we have two terms multiplied to give you 0. One of them has to be 0. Either x is 0 or x is 4. So this is the other place where they intersect at, when x is 4. Now these are x numbers. They're not going to be directly the numbers that we end up using, because our integral is in y. Okay. And so basically we take these functions here, y equals x over 2 and y equals root x. We need them x equals. We need formulas of y. And so taking the first one, y equals x over 2, then we double to get x is twice y. And then the second one, y equals root x, we square to get that x is y squared. And that's the form that we need these guys in. They were given to us in y equals form, but it turns out since we're doing it in y, that we had to switch them to be x equals form. Now it's our job to find the inner and the outer radius. Remember, what the outer radius does is it goes from the axis of rotation through your region. So the outer radius would be this distance to the line. Now this x equals y squared is the root, and this x equals twice y is the line. And remember that the distance off the y-axis is x, and so that makes this outer radius twice y, the distance to the line, the x distance to the line. So that's twice y. The inner radius goes from your axis of rotation just up to your region, and that's the distance off the y-axis to the curve. So that's that x distance, which we called y squared. So we have our outer radius, we have our inner radius. Now we're just going to set up the washer formula where we take the outer radius and square, and from that we subtract what we get when we square the inner radius. And we integrate from some a to b. But remember though, this is y. We're integrating with respect to y. And so the a would be 0, but to get the b, this x equals 4 that we found, plug it into either formula, will tell us then that y is 2. So the limits of integration aren't this 0 and 4, these x numbers, we have to translate them to be 0 and 2 for y. And there we have it. We're integrating pi times the integral from 0 to 2, taking 2y and squaring it, and from that subtracting y squared, quantity squared. And now it's all down here. Most of this, is set up, and from here it's just an integral that's simple to do. Square the 2y squared, we get 4y squared. Square the y squared, we get y to the 4th. Power rule in reverse, to perform the fundamental theorem of calculus, we get 4y cubed over 3 minus y fifth over 5. Evaluated from 0 to 2. And so we plug a 2 in, and we're talking about taking 2 and cubing it to get 8, timesing it by 4 to get 32. But then watch, when we take 2 to the 5th, we also get a 32. So we get 32 over 3 minus 32 over 5, and officially plugging in 0 gives us 0. And so lastly then, to finish this out, we don't want to make it a common denominator of 15 yet. What we'd like to do once again is recognize these 32's are in each of these, and we're going to factor out the 32. We'd much rather deal with 1/3 minus a fifth than 32/3 minus 32/5. Okay, and so then we get a common denominator of 15, and so we have 5 of those 15's, and we take away 3 of those 15's. So we have 2 of those 15's, and we take the 32 together with this 2 for a final answer of 64 pi over 15.